Okie dokie, folks. Today's topic, function translations. Before we get to that, let's just review what a function is, shall we? Let's say, for example, we have the function f of x equals x cubed. We can think of that as a transformation applied to numbers. So this function f is going to take in a value x, and it's going to spit out a value f of x. Think of a vending machine. Takes in money, spits out a carbonated beverage. Let's look at some examples, shall we? All right, so -1 goes into this function f, and then what does it return? Well, it should return -1 cubed, okay? Which is -1 times -1 times -1. So -1 times -1, that's +1, multiplied by -1 one more time, -1. Okay, what if we put 2 inside this function? Well, it's just going to return 2 cubed. 2 times 2 times 2. That's easy enough. That's 8. All right. What if we put in, oh, I don't know, let's say 3. Well, 3 cubed, 3 times 3 is 9, times 3 again, 27. Okay, so in each of these cases, we can say that f of the input value is the output value. For instance, we can write f of -1 is -1. F of 2 is +8. And finally, f of 3 equals 27. Pretty simple, huh? Now, you might hurt your hand if you always write f of whatever equals whatever. So, make it a little easier on us. We can store that same information in this t-chart. So for various input values, on the left, we can write the output values on the right. For example, let's say we want the inputs to be the integers from -3 to +3. We're going to write these all on the left. Now the outputs we're going to write on the right. So we already know that f of -1 is -1. So the output here is -1. Similarly, we already know f of 2 is 8. So the output here is 8. And f of 3 is 27. What about these other values here that are missing? Well, f of 0, 0 times 0 times 0, that's a big fat 0. F of 1, 1 times 1 times 1, that's a big skinny 1. F of -2, well, negative times negative is positive. -2 times -2 is +4. And then you multiply by -2 yet again, switch back to -8. And similarly, f of -3, -3 times -3 times -3 is -27. Okay? So for this function, f of x, we've just generated a table demonstrating the outputs corresponding to various inputs. But what if we had another function? Imagine that we had not only f of x, but we had a different function, g of x, which is equal to x cubed plus 2. We could also put the output values of g of x in our table. So if I had another column here, g of x, we could put the output values corresponding to the same input values. And these are easy enough to compute, because g of x is just this guy, which was f of x plus 2. So what's the output value for negative 3? Well, it's just f of x, negative 27, plus 2. So negative 27 plus 2 takes us to negative 25. Similarly, the output value for negative 2 is this plus 2. For this, it's this plus 2. This plus 2. Okay, so we're just adding 2 to the column for f of x to get the column for g of x. All right, so now we made our table, but we haven't answered the big question yet. Big question is, how are the graphs of f of x and g of x going to compare? We'll wait until you find out.